25 asks to find the standard deviation for the grouped data here. So I know you can do this with your calculator. I will show this using using the longer kind of drawn out approach. And let's first write the formula for the standard deviation, S. So let's see, square root of the sum of the x squareds minus n times the mean squared all over n minus 1. That's the shortcut formula, the simplified formula that the book gives. This is the formula we'll use to find the standard deviation here. So the first thing I want to do is find the mean, find x bar. And this is a grouped frequency distribution table, so it's going to be a little bit more challenging to find the mean here. But in order to do that, for each of these intervals, let's find the midpoint. The midpoint of each interval, because in order to find the mean, I need a value. I need a value to use. But since this interval is 50 to 59, there's no set value. So the midpoint of 50 to 59 is 55. 60 to 69 is 65, 75. So there's my midpoint. So this is my value I'm going to use. So essentially, it's like I'm saying I have 8 55s. I have 5 65s, 5 75s, 5 85s, 17 95s. I'm going to use that to find my mean, my x bar. So I'm going to do this in the calculator because it's a little easier to do that way. And I'm going to use this calculator here to do that calculation. So again, I have 8 55s, so I'm going to do 8 times 55. Now, if you have a two-line display calculator, this will work really nicely. 8 times 55 plus 5 times 65 plus 5 times 75. It's better than saying 75 plus 75 plus 75 plus 75 plus 75. I'll just use 5 times 75 plus 5 times 85. I've got 5 85s. And then, it really helps here, 17 95s. So added up all together, that's 3,180. So that's my numerator here, right? So x bar equals 3,180 divided by, that's the sum of the frequencies times the midpoint. But I need to know how many values I have. I need to know n, right? So to find n, I'm going to sum the frequencies. N equals the sum of these frequencies, which is 8 plus, so 5 plus 5 is 10, 10 plus 5 is 15, 8 plus 17 is 25, 25 plus 15 is 40, so I've got 40 values in all. 3,180 divided by 40, that's 7, 9, 5, I believe it is. So 79.5 should be my mean. Let's double check. 3,180 divided by 40 equals 79.5. I still got it. So my mean is 79.5. So if we're using this formula here, we've got one component of it. We've got n, we've got x bar. Now we need to find x squareds, the sum of these x squareds as well. So my midpoint here is going to be my x value. Those are my x values, right? These are my values, 55, 65, 75, 85, and 95. Now I'm just going to square each of these. 55 squared, 55 squared, 65 squared, 75 squared, 85 squared. So let's start writing these in. 3025, 4225, 56, 25, 72, 25. It might be 90, 25. Is that what that's going to be? 95 squared. Oh yeah, 90, 25. Okay. So these are my x. I squared each of my midpoints. These are my x squared values. Now I've got to sum these. I need to add these up. I'll do that here too. Might be faster by hand though. 30, 25 plus 42, 25. Yeah, see, because of that. Using this stylus here to try to type these things in. Plus 72, 25. Oops, it did it again. That 2 key. Plus. Well, if I did anything wrong here, you'll let me know, right? 30, 25, 42, 25, 56, 25, 72, 25, 90, 25. Add them all up, 29, 125. Okay, so let's... Wait a minute. I made a little mistake with this formula here. Nobody told me the standard deviation for the group data. This should be the sum of the frequency times x squared. That's what I need. So I don't really need, this is not the sum I really need. I need to multiply this times the frequency and add that up. So frequency times the x squareds. So we've got to multiply here and then add that. I'm going to do that on my calculator in front of me. So, sorry, I have to adjust this here. Okay, so frequency 8 times 30, 25. That's 24, 200. 5 times 42, 25. That's 21125. 5 times 56, 25. 28125. 5 times 72, 25. That's 36, 125. 17 times 90, 25. That's 153,425. Now we're finding the sum here. So 24, 200 plus 21, 125 plus 28, 125 plus. Okay. So the sum should be 263,000. So I'm going to continue with my formula now. Let's see if this all works out. So the sum of the frequency times x squareds, that's here, 263,000 minus n, which is 40, times x squared times 79.5 squared, all over 40 minus 1, and minus 1. So this first line, if you have a 2-line display calculator, sorry, you can type that first line in the numerator directly. 200, turn on, 263,000 minus 40 times 79.5 squared. And so my numerator, I didn't even see it. So that's 10,190. 10,190 divided by 39. Well, I mean, if you do this all in one step, you'll get a very accurate answer here. Okay. So I'll do it on this calculator here, the square root. And this is already in parentheses here. The parentheses already opened up for me. So I'm just going to type this expression divided by 39. Close my parentheses. And I get 16.16, which I round to 16.2. There's my standard deviation. What a process. Now, depending on which kind of calculator you have, your calculator can do this for you, right? So you might have to consult your calculator. I can show you how it's done on this calculator. And it's very similar to how it's done on the TI-36, TI-34. They're all done very similarly to this. You either have to press it. Some calculators have a data button where you input data. Some calculators you have to input the data each step. But here, so if I go to Stat, Edit. Oh, I already have some data in here, don't I? Okay, let's do this. Let's clear. Enter. Let's clear. Okay. So I'm going to enter my values, my X values in the first column. 55. Oh my gosh. 55, enter. 65, enter. 75, enter. 85, enter. 95. Those are my values. And in my second column, I'm going to input my frequencies because the calculator needs to know, well, how many of these values do you have? So I'm inputting my frequencies right next to the data point. Now, when I go back to statistics to calculate, we're using one variable, X, so one variable statistics, and my data is in L1. You have to tell the calculator this in some way. On some calculators, there's a screen that says values, L1, frequencies, where the default is 1, but you can tell them, hey, the frequencies are in L2. On this calculator, I have to input it in this way. So my data is in L1, my frequencies are in L2, enter. There's my mean, 79.5. There's the sum of the X values. I think we can find that. The sum of the X squareds. There it is. The standard deviation, 16.16. That's what we got. Population standard deviation. The number of values, that's N, that's 40. What else? The smallest value is 55. The first quartile. The median. Third quartile. The maximum value. It gives you all of that. So if you can figure out how to do it on your calculator, if you want to come and ask me directly, fine, either way. But yeah, so this is the approach. If you can't figure out the calculator, you aren't allowed to use the calculator for this. And this is a kind of one version of the calculator approach.